Hello, today we're going to be talking about solving equations by adding or subtracting. The goal of today's lesson is to be able to solve one-step equations in one variable by using addition or subtraction. So, the first thing we're going to talk about is what the solution of an equation is. Replacement for a variable that makes an equation true is called the solution of the equation. So down here in these examples, example 1, x equals 3 is a solution to x plus 4 equals 7. I'm telling you that x equals 3 is a solution, but how do we know that? Well, we can replace this x here with 3, because x is equal to 3. So I'm going to replace my x with 3. 3 plus 4 is equal to 7. 7 equals 7. So this is true. Example 2 here, x equals 8 is a solution to x minus 3 equals 5. So again, I can replace my x here with 8 because x is equal to 8. So 8 minus 3 is equal to 5. I would say that 5 equals 5. So when we talk about solving an equation, that means we're going to find all of its solutions. So here, 3 is a solution to this equation. This is an equation. This x plus 4 equals 7. That's the equation. And then 3 is the solution. I'm going to determine whether the given values are solutions to the equations. In the first one, I have x minus 18 is equal to 33. Is x equals 41 a solution? So, just kind of like in the last one, we can find out if x is a solution by replacing x with 41. When I do that, when I replace this x here with 41, because x is equal to 41, we will have 41 minus 18. Now, if 41 minus 18 is equal to 33, then 41 is a solution of this equation. And then if not, 41 is just not a solution. So we need to state whether or not they're solutions. So I'm going to replace this x here with 41. And then I'm going to simplify this. 41 minus 18, 23. And 23 does not equal 33. So this is not a solution. And then I put this slash through my equal sign here, because that means that they're not equal. Let's look at the second one. X plus 27 is equal to 51. Is x equals 24 a solution? Once again, we can find out if x is a solution by replacing x with 24 in this one, but replacing this x with 24. So I'm going to do that, and I'll have 24 plus 27 is equal to 51. So I'm going to simplify 24 plus 27, that is 51. So before we go on to the problems, we need to talk about some principles for this. And we're going to talk about equality principles, to be exact. And so for any real numbers, a, b, and c, so if a is equal to b, if a equals b is true, then a plus c equals b plus c must also be true. And the same thing for subtraction, a minus c is equal to b minus c. Meaning, if we know a equals b is true, then we add the same number to both sides. So that's a equals b is true, and we're adding c. We're adding the same number to both sides. The resulting equation must also be true because we just added the same number to both sides. And the same thing is true for subtraction. If we know that a equals b is true and we subtract the same number from both sides, our resulting equation must also be true. And I did that here with examples with actual numbers. So how are we going to use the equality principles? Well, we're going to use them here by the goal of solving an equation is to isolate the variable on one side of the equation. So in this lesson, we are going to add and subtract numbers on both sides of the equation to isolate the variable. We're going to be talking about isolating the variable, or we're going to be working with isolating the variable a lot in the upcoming lessons as well. So now we're going to solve each equation. And I know that with some of these equations, you can probably look at them and determine the solutions that we want. But the point of this is to develop some skills to solve the equations when they become more complicated. And this way we are forming good habits. So now we just talked about isolating the variable. What does that mean? We want to get the variable, which is y in this case. We want it to be by itself on one side of the equation. So you don't want, and by one side of the equation, the equal sign, that's what splits up the equation. So right now the 24, that's by itself on one side of the equation. We want to get y by itself. We want to isolate the variable. And what's our first step in doing that? Well, I have 8 subtracted from this side. So if I add 8 to this, if I add 8 over here, I will eliminate 8. So what I do to one side, I have to do to the other side. So I'm going to add 8 to both sides. I'm going to add 8 here. I'm going to add 8 here. And so negative 8 plus 8, that's going to cancel out. And then I'm just going to be left with a y. And over here, I'm going to have 24 plus 8, and that's going to be equal to 32. So y is equal to 32. Now, how do we know, how can we determine if this is the correct solution? Well, we can check it. And I'm going to start with my original equation now, because I'm going to take this, y equals 32. If it equals at 32 down here, it's going to equal 32 in here, or at least it should. So, let's start with my original equation, y minus 8 is equal to 24, and then replace y with 32. 32 minus 8 is equal to 24. I'm going to simplify, 24 equals 24. Perfect. Let's look at this one. So, I have 43 is equal to x plus 9. What do I need to do to isolate the variable? I need to subtract 9, because we have 9 is being added to it. And the reason that we subtract is that is the inverse of adding is subtraction. So I'm going to subtract 9 from both sides. And then these two are going to cancel out because we have a positive 9 and a negative 9. That's going to cancel out. And we're going to have 34 is equal to x. And once again, we're going to go back and check our solution. And we can do that by replacing x with 34 in the original equation. So I have 43 equals 34 plus 9. 43 equals 43. So we can look at our next ones. 5/16 is equal to x minus 7/16. So it's the same thing when we have fractions as when we have whole numbers. And I still want to get x by itself. But what's happening to x? X minus 7/16. We need to get rid of the negative 7 over 16 in order for x to be by itself. How do we do that? We're going to do the inverse. So the inverse of negative 7 over 16 is going to be positive 7 over 16. We're going to add 7 over 16. What we do to one side, we have to do to the other side. So add it to both sides, and then these two will cancel out. And then I'm left with 5 over 16 plus 7 over 16 would be 12 over 16, and that's going to be equal to x because it's the only thing left over here. And I'm going to reduce this. That'd be 3/4 x. And once again, just to be sure, we're going to check our solution. So we always start with our original equation when we're checking our solution. And I'll have 5 over 16 is equal to x minus 7 over 16. And then I'm going to replace x, and I'm going to replace it with 12 over 16 just to make it easier so that they all have a common denominator. And I'm going to simplify. 5 over 16 is equal to 5 over 16. Now on this one, we have decimals. Don't be scared when they're different than whole numbers. Fractions, decimals, it's all the same. So 4.2 is equal to t plus 1.8. Now I'm going to subtract 1.8 from this side and this side. And I'm doing that because we're being added here. So I want to do the inverse, which is subtraction. So I'm going to what I do to one side, I have to do to the other side of the equal sign. I'm going to subtract 1.8 from both sides. These two are going to cancel out. A positive 1.8 and negative 1.8. And then I'm going to end up with 2.4 is equal to t. And go back and check our solutions. 4.2 is equal to t plus 1.8 is our original equation. I'm going to put 2.4 in for t. And I'm going to simplify. And I get 4.2 is equal to 4.2. So it is a solution. Last one of this. Negative 5 over 11 plus p is equal to negative 2 over 11. So what do I need to do to isolate the variable? Now, don't be confused, because do you see that this is being added to P? If I were to subtract, because don't do the opposite of this. You want to do the opposite of what the constant is that we're trying to get rid of. So this is a negative 5 over 11. So we need to do the inverse of this negative here, not of this negative. So we're actually going to add 5 over 11 to both sides. And we do that because, see, then they cancel out, because that's the goal. We want to cancel them out over here. And when we do to one side, we have to do to the other side. So like I said, those cancel out. And then I'm left with P equals 3 over 11. And then I want to check my solution. Always check your solution. Start with our original equation. Replace P with 3 over 11. And negative 5 over 11 plus 3 over 11 is negative 2 over 11. One more thing about these, and I guess I messed up a little right there, was when you are solving these, it's always helpful if we keep our equal sign like generally straight up and down from each other as much as you can, because it just kind of keeps everything lined up and helps us stay organized with where our numbers are at and where our variables are at and which side of the equation they're on. So, last one is we have a word problem. So, it says, if after writing a check for your rent in the amount of $650, the new account balance is $437, what was the beginning balance? So we need to start with, we need to write an equation out. In order to do that, we're going to need a variable, and I'm going to use x. I like using x. So what is x going to be in this case? Well, what are we looking for? We're looking for our beginning balance. So x is going to be my beginning balance. And so then from that, we can start forming an equation. So it says that if after writing a check for your rent in the amount of $650, so we're writing a check for $650, we are subtracting $650 from our beginning balance. And that is going to be equal to our new account balance, $437. So x minus 650 is equal to $437. I'm going to solve this for x. I'm going to isolate my variable. I'm going to do the inverse of minus 650, so I'm going to add 650 to both sides. These ones are going to cancel out, and I am going to be left with x is equal to $1,087. So now when you're done here, make sure that you are labeling this, because we are talking about the balance of a checking account. And let's go back and check our solutions just to be sure. I'm going to start with my original. And then I'm going to replace x with 1,087. And 1,087 minus 650 is equal to 437. So that looks good.